Hello friends, I'm Rizwan Ansari. Throughout this course, we will do deep dive on Azure Machine Learning, which is a great Microsoft platform through which you can create, maintain, and distribute the real-world machine learning solution. Here are the topics I will be covering throughout this course. We will already completed the machine learning introduction and its type in previous videos. Machine learning workflow and machine learning, Azure Machine Learning will be elucidated through this video. Now in this part of video, I'll illuminate about each step of machine learning workflow or process. What's more, I will introduce the Azure machine learning, its possibilities, why we choose Azure machine learning, with the illustration with Azure machine learning infrastructure requirements. Before jumping into the main content, I would like to recap my previous video, Azure machine learning introduction, which we did in the first part. Azure machine learning is a tool for turning information into the knowledge. Machine learning is a subset of artificial intelligence that uses the historical data as an input to predict the output on the new data without using any static programming. Different approaches or methods are there for the machine learning. Supervised, which is based on the level data, where we solve the regression or classification problem. Unsupervised, where we have only the input data and those are unlabeled. We identify the hidden pattern inside the examples data or input data. Similarly, semi-supervised. We mixed up a small amount of labeled data into large amount of unsupervised data, which add a lots of advantage and upon possibilities to solve many machine learning problems. The last one, reinforcement, which is new and complex in nature, whose principle is based on rewards and motivation. So Azure machine learning workflow. It starts with asking a right question or right problem. Azure machine learning workflow starts with defining a specific question or problem with a defined boundary. A right question will lead to you know about the data, its preparation, identifying algorithm, testing the model, and overall outcome of the model. Some examples like you need to predict the individual risks based on the information they give on the credit application. So credit risk assessment is a complex problem. However, the machine learning can add new dimension for effective analysis. So if you know your problem, you know what kind of data you need, what kind of algorithm you are going to choose, training, and then evaluation. So having right question, right problem is most important part of Azure machine learning. Now, this is the most important phase, that is data preparation. So in machine learning solution, which is absolutely depend upon phase one or first part. If you know the problem, you know about the data preparation. Defining the problem accurate question leads to know about the data and its preparation. It is one of the time consuming phase, like almost you will spend 60% of overall time in the data preparation itself. Data preparation in general means transforming raw data into formatted which can be modeled through using machine learning algorithms. This phase includes number of sub-steps like data cleaning, filtering, manipulating, scaling, and reduction, sampling, and splitting. Furthermore, the actions which are carried out for data cleaning or manipulating are like adding or rows or columns, cleaning the missing data or replacing with mean or median, editing metadata, joining data, removing duplicate rows, categorization, and many more. Another important point I would like to highlight here, whatever the data we get, we split that into two parts. We use most of the data for the training and we keep some of the data to test our model. Like normally we use 80% of our data for training and 20% to test our model. Now selecting algorithm, which is solely depend upon your first phase, that is problem. Based on your problem, you know what kind of machine learning algorithm you need. There are numerous well-established algorithms available and are already applied for machine learning, ready for applying for machine learning solution. Anomaly detection, classification, clustering, regression are the types of model or algorithm which are categorized based on the problems. There are furthermore many matured algorithms that are available for each category. For example, uh, regression, you have a linear regression, neural network regression, two-class decision forest, multi-class decision jungle, k-means clustering, PC-based anomaly detection, etc. As a machine learning solution, we never work on designing or creating the algorithm. That is not the part of designing the machine learning solution. Nevertheless, we only do trials with different established algorithm and find the suitable one for our problem. Now, training model. This is also known as fitting stage, where the prepared data and formatted data are used with selected algorithm to train the model. The process alternatively means model that will learn from the training data. Testing and evaluating the models. In the earlier stage, data that we split it for training and then some data we keep for testing. Based on that testing data set, in this stage we use that testing data to check the score of the model and to know how well it is performing. Test data are fed into the trained model and we evaluate the outcome with actual to know the accuracy level. Most of these phases are repetitive, depend upon the result of testing and evaluation. If the evaluation score is below the expectation, then again the process will step back. We again change the algorithm, then again we go for training, then again we go for evaluation. So this process is repetitive and we need to find which algorithm fit for our problem based on accuracy level. So this is a continuous process. Sometimes we may need to jump back to the data preparation itself based on if our evaluation or if our expected result is not up to that level. Then we go again, we prepare or we modify the data. Again, we select the proper algorithm or suitable algorithm, train the model, and again testing and evaluation, check the results. So we repeat this process until we get our expected accuracy. Then another important phase is maintenance. That is one of the crucial part to maximize the model, where new or recent data are again fed into the model and processed through all the process so that our model will be keep on updating and the accuracy level will keep on increasing. So in some cases we might need to change the algorithm as well. Now Azure machine learning. By this time, Azure has become the most common word for cloud computing platform and services. Azure Machine Learning is a growing collection of integrated cloud services. With that, it gives a cloud environment for designing a complete machine learning solution where we can train, deploy, evaluate, automate, maintain, track the model. You'll have your workspace for conducting machine learning experiments. This platform can handle all the scenario of machine learning, starting from classic machine learning to deep learning, also suitable for supervised as well as unsupervised approach. Whether you want to prefer to write a Python code or R code with SDK or work or no code, low code, drag and drop options, you can build, train, and track the machine learning, deep learning models in the Azure Machine Learning Studio or Azure Machine Learning Workspace. So you have both options. You can write all the codes. You can use drag and drop option to design a complete machine learning model. The service also integrates with popular deep learning and reinforcement open source such as PyTorch, TensorFlow, Sklearn, many more. Now, why we are choosing Azure Machine Learning? So far, we have discussed the traditional machine learning process, which has been used over and over to create the machine learning model. These training models obviously is a heart of solution. However, having this model is only part of complete solution. Furthermore, we need additional infrastructure to complete the machine learning solution. So Azure is not only limited for training. Still, you have other infrastructure requirement that you can fulfill through Azure machine learning. Now let's explore the machine learning infrastructure requirement. To build a complete solution, you need a place to manage the data. Then you need an environment to sufficiently build machine learning algorithm to test it, to train it for data preparation. That is we call workspace to build the machine learning model, run through experiment. Soon after, we need to deploy the solution to use the full capabilities of the application. Then again, we need to be able to manage the access of the solution, likewise giving the key so that only authorized user can access our machine learning solution. Finally, we should be able to maintain our machine learning solution because sometimes your data will be updated. Sometimes we need to change the algorithm. Sometimes scope gets changed. Sometimes requirement gets changed. So maintenance is another part infrastructure requirement. So all these infrastructure requirements which can be achieved through a single platform called Azure. That's why Azure is an ideal platform for machine learning. So there are numerous services available in the Azure which is updating daily basis. Besides, new services are adding on regularly. However, I'll highlight some services considering for our machine learning. In Azure, you have an option to have a on-demand computer resources. You can scale up or you can change the plan at any point based on your requirement. Data storage, file, disks, blocks, data log, SQL, Azure SQL, document DB, table storage. Then you have an analytic service like machine learning integrated environment where you can develop the model. Then you have we have lots of web services like for container app service to publish the solution. All this solution you have option to do schedule backup, network and bandwidth configuration. Lots of development tools are available in the web services, app services, off service plans are there. Authentication and authorization you can add, and there are ample of other valuable options. Now let's take a scenario or let's take a complete picture how these resources are connected. So first we need a data or a storage area. So that is, and those data are huge data. So those data we send it to the, firstly we use that storage resources for machine learning like blob, table, SQL. Then we fetch those data to integrated development environment for machine learning where we clean the data, train it with algorithm, evaluate the model. Once our model is ready with expected accuracy, we publish or deploy using the web services. Then we need to consider about access control, which is important for exposing our solution to the clients. Therefore, only authentic clients can use your solution. We all have these options in the Azure, like for storage, you have Blob or it's SQL DB, Azure SQL DB. For development platform, you have Azure Machine Learning Studio. For API publish, you have a web service, app service, and or containers. So with all this, we have access control. So that's how this all resources are connected, and these all resources or these all infrastructure requirement can be met through one platform, that is Azure Machine Learning. That's why Azure Machine Learning is an ideal platform for developing a machine learning solution. So in next video, we will explore a bit more about Azure Machine Learning Studio. We will take a particular problem. We will drive through all the workflow processes like cleaning, choosing algorithm, training, testing and evaluation. Then we will publish it and evaluate, and we will discuss about the maintenance in the further videos. Thank you for all giving your time.